Assalamualaikum and hi everyone. My name is Amisha binti Mahizan, matrix number A175395, and today I will present about safety in radiography. Radiography is of vital importance in non-destructive testing. Radiography ensures the integrity of equipment and structures such as vessels, pipes, welded joints, casting, and other devices. Radiography can also produce high-dose rays so that a person accidentally exposed to the primary beam or in close contact with an unshaded source might within minutes or even seconds receive a dose that results in injury. This aspect indicates that the need to achieve a high degree of professionalism in radiography, using sources, devices designed to the highest standards and working in an environment that promotes a safety culture. This can be accomplished by means of an appropriate national and organizational infrastructure, effective training of workers, compliance with safety requirements, and effective quality control, together with good design, manufacture, and maintenance of sources and devices. So here are the objectives that we will want to obtain throughout the slide. The first one is to prevent predictable impacts in individuals by keeping doses below the relevant threshold and to reduce unpredictable consequences in the group now and in the future. The second one is to protect individuals, society, and the environment from harm by establishing and maintaining effective defenses against radiological hazards from sources. Industrial radiographers have an important responsibility for ensuring the safe conduct of their work. Their safety and that of other workers in the immediate vicinity depends on their observance of a high standard of radiation safety at all times. The public and other persons who are in the immediate vicinity when radiography is in progress can be adversely affected if the work is not carried out to the required level of competence. So, the first aspect that we will look is from the operator or personnel point of view. So, here are the safety regulations for operator and personnel. The first one is the radiographer needs to achieve a level of competence by study and training, which is recognized and accepted by the appropriate professional bodies. The second one, each radiographer has to receive any medical examination as approved by the regulatory authority to confirm the fitness for work with ionizing radiation. The third one, in difficult and adverse conditions of industrial sites, the radiographer also has to consider non-radiological hazards and to wear appropriate protective equipment. The fourth one, the radiographer need to wear suitable dosimeters as directed by the RPO during the working time to measure the total exposure to radiation. The fifth one, the radiographer should not expose him or herself or others to the radiation unnecessarily to ensure that the dose he or she receives is as low as reasonably achievable. Next, all necessary care is to be taken to maintain radiography and ancillary equipment in the condition necessary to operate safely. And the last one, the radiographer is to perform all appropriate survey to assess radiation hazards. So, moving on, most radiography is performed on site and is influenced by a number of site-specific conditions. Planning for safe operation includes consideration of the location, proximity of members of the general public, weather conditions, time of day, and work at height in confined spaces or under difficult conditions. Owing to this type of conditions, site radiographer needs to be performed with more than one radiographer. So here are the procedure steps on to ensure the safety at the on-site radiographic testing. The first one is preparation that we need to do before start working. The next one is the procedure in the exposure room, and then the procedure in open sites and the radiographic boundary example. Alright, so for preparation before working, we need to ensure that personnel should be equipped and be ensured to wear monitoring devices. And then they have to ensure that the survey meter of radiation are the appropriate to the type of radiation used, and the response of the instrument should be appropriate to the type of radiation. The next one is for the warning signals are important to warn the surrounding public because it used to warn people around the area of the presence of radiation. Same goes to the radiation signal. They should be included in the working place. The warning sign should be in the form of light or audible signals or both. The light or audible signal shall be distinguishable when the seal source is exposed or an X-ray machine is energized. Warning and radiation signs should be made in adequate size, and it is suggested that the name, address, and telephone number of the person responsible for the site to be included on each warning sign. Alright, the next step is for the procedure in exposure room. The area within the boundary must be kept under surveillance at all times during the exposure to ensure that no one can enter it or remains within it. Only the authorized radiographer are allowed in the exposure room, and if the exposure room is designated as a controlled area, it is appropriate for the authorized workers to have medical examinations. Radiographer also need to always wear dosimeters and record all the results obtained, and written operating procedures should readily available as appropriate. Alright, moving on to the last step in procedure step. If there should be any movement of radiation sources outside the premise, it shall comply with the Radiation Protection Transport Regulation 1989. On the arrival site, the radiographer must obtain permit to work and inform the area supervisor about the type of radiographic source, model and serial number, name of radiographer, type of radiation safety equipment, period of works, and sketch site plan. After the location of the radiographic work has been identified, the boundaries for control area shall be clearly defined with the barriers of rope or other means. The warning light shall be displayed to indicate the radiographic exposure is underway, and the area shall be kept under surveillance at all times during exposure. The radiographer must be at frequent intervals measure the dose rate to ensure that the rope is correctly placed. After the work is complete, the source will be returned to the container and be locked. Make sure to use the survey meter to confirm safe position of source, and then return the container to the storage or vehicle and inform the supervisor in charge at the area. Alright, so here is the example of a graph of picture on site about radiographic boundary.